Hi students, this is your lesson 5.3 and we are going to be solving rational equations, power equations, and reviewing trig equations as well. So this video is going to really focus on the rational and the power equations. Okay. So our learning goal is I can solve trig, and this is obviously we've done a lot of this last semester, rational functions, rational exponents, and power equations. So we're going to kind of wrap all that together in this learning goal. Same criteria for success. And what I'd like you to do is try to work through the problems 1 through 29. It's in your packet, page 10 to 11. So I would love for you to take about 5 or 10 minutes. You can pause this and start working through. I have the key for 1 through 29. The key is on your Schoology folder, the classwork folder. Okay, so you can go ahead if you feel pretty good with those 1 through 29, check with my key. I am going to actually continue the video to go through all of them. No matter what, if you do that on your own and check it and you're good, you're going to want to skip to the end of the video because I'm going to do some actual solving questions with you, problems 30 to 32 at the end of the video. Okay, so hopefully you've already tried some of these on your own, and some of this is going to be just a quick little refresher. So this first part is asking you to write all the reciprocals. And for a reciprocal, we're going to just reverse the order of the numerator and the denominator. So these are not equivalent, they're not equal to each other. You could probably put a little comma if you want to separate them, but they're definitely not equal, and those are the reciprocals. Now, if we want a product to equal 1 and we're given some original value, if we multiply by that reciprocal, we're going to get 1 each time. So in this case, we're just going to go ahead and write in each reciprocal here. And we know when I multiply a number by its reciprocal, we will always get 1. Okay, what is the meaning of x? So when you see x, basically what you need to remember is it is x to the first power. It's not x to the 0. Remembering x to the 0 is always equal to 1. Any value to the 0 power is going to give you 1. Okay, how do I make x to the a equal to our, or how do I create so that it's x to the first? So what we want to do is multiply this little exponent of a by 1 over a, which is the reciprocal. So I actually want to multiply the little exponent of a by 1 over a, and that would create x to the first. So fill in the blank to make the exponent equal to 1. Again, we're just going to go ahead and write in those little reciprocals. So each time I do this, I should get x to the first. And this is all going to lead up to our tools for solving. So just some little exponent refreshers. Okay, so to undo a square, and we've done this with our quadratics when we've solved, to undo a square, we take the square root. So that's saying, if I have x squared is equal to 9 and I want to solve, how do I undo that square? I take the square root of both sides and I get x is equal to plus or minus 3. So we know that that's how we undo a square. In number 15, we raised a square to what power? We raised it to the 1/2 power. So we write 1/2 in here, and that undid the square. Does that mean they are the same thing? Yes, they are. So we know that x to the 1/2 is the same as the square root of x. You could write this little index in here as a 2. Normally, you do not see that for a square root. For a cube root, a fourth root, you will always see the index shown. But for a square root, typically, we don't see the little index written in here. Okay, so if x to the 1/2 is the square root of x, then 9 to the 1/2 is the square root of 9. And we know that that is equal to 3. Now, you might be asking, hey, how come no plus or minus here? We only use a plus or minus if we have an equation and we take the square root, or actually an even root, of both sides. Okay, if you're just evaluating and I say, what is the square root of 12? Well, that's some decimal. It's just whatever that value is. It doesn't magically turn negative as well. Okay, this is saying, hey, there's some unknown value here. What number, if I square it, equals 9? Well, there's two numbers that work, 3 and -3. In this case, this is a positive number. It stays positive. Nothing there changes, okay? So plus or minus is only when we're actually solving an equation and we take an even root of both sides of the equation. All right, so moving along here, 64 to the 1/2 is the square root of 64, which we know is just 8, because 8 times 8 is 64. 36 to the 1/2 is the square root of 36. And that answer is just 6. And again, we're not solving anything. We're just evaluating. That's all. Okay, what about other fractions? So the square root is actually the second root of a number and can be written. So here's where they show that little index. Okay, and these all are equivalent. Now, if my little index is 3, this is going to be to the 1/3 power. Now, where does that 1 come from? That comes from the exponent right here. So it's x to the first. So it's 1/3. That is what we would write if we wanted to write it with an exponent. This next one would be 64 to the 1/6. Notice the index is always the denominator. And this would be 81 to the 1/4. Okay, now is when we get some weird stuff going on here. And of course, we're going to get a little bit messier. We have a fraction like 2/3. Okay, so 2/3 is equivalent to 2/1 times 1/3. Because we know when we multiply fractions, we multiply their numerators. 2 times 1 is 2. 1 times 3 is 3. It also works if we write it this way. 2 times 1 is 2. 1 times 3 is 3. Okay, so let's take a look at multiplying these powers. We're taking a power of a power, basically, because we have x squared, and we're raising that to the 3rd power. So we're going to use x squared 3 times as our base. 1, 2, 3. So how many x's do we have? Well, we have 2 here, 2 more here, and 2 more here. So that is x to the 6th power. This next one, again, we would have x to the 4th twice, which gives us a total of 8 x's. Here we'd have x to the 20th, x to the 70th, and x to the 200th. Now, when you have a power to a power, like we just looked at in the previous examples, you multiply the exponents. So x to the a raised to the b power is equivalent to x to the ab, to that product. Okay, so we're back to that x to the 2/3. We said 2/3, the value is the same as 1/3 times 2. Here's the 1/3, here's the 2. We also know that raising x to the 1/3 means the cube root of x. And then we keep that square. Now that is exactly the same if we wrote the product in the other way. So x to the 2/3. We have 2 times 1/3. That's exactly 2/3. That's perfect. Okay. The 1/3 power means the cube root. And what are we taking the cube root of? X squared. You can write this either way. Sometimes it's going to be more beneficial to write it one way or the other. It'll make it a little more simple, but either way is going to give you that same answer. So for this next one that we're looking at, this is the same as saying x to the 1/5 raised to the 3rd power. Well, how would I write that with a radical? It's the 5th root of x cubed. Or, here's another way to write it. X cubed raised to the 1/5. Okay, well, the 1/5 is still my fifth power, or sorry, fifth root rather. And fifth root of what? Fifth root of x cubed. This one is x to the 1/2 raised to the 7th. Because 1/2 times 7, remember that's 7 over 1. You multiply numerators, denominators, and you get 7/2. So that's the square root of x raised to the 7th power. Or x to the 7th raised to the 1/2. Okay, we're taking the square root of what? Of x to the 7th. And then the last one here, and then we're going to get to our actual solving. This is 16 to the 1/4 raised to the 3rd, which is the 4th root of 16 cubed. I didn't mean to put that little equal sign in there. And then the other way we could also write this is 16 cubed raised to the 4th. That's the 4th root of 16 cubed. So you want to make sure that you can practice this and you're able to smoothly go from exponential to the radical form. And now we're going to go ahead and break out some of the solving. So the 3 questions we're going to do here for solving, same types of steps. We want to isolate that variable. We want to find out what is the value for the variable. So this first one, right now, my variable is trapped by this exponent. So the tool that we're going to use is we're going to actually raise both sides to the same power. What can I raise it to make that power or that exponent become a 1? We're going to raise it to the 2nd power, the reciprocal, right? So 1/2 times 2 is just 1. So we're left with 2x minus 1 to the 1st power, or just 2x minus 1, and that equals 81. And now we're back to just a regular 2-step equation. We add 1 to both sides, we divide by 2, and we have our solution. Check all solutions. Make sure you at least mentally plug that in. Look for extraneous solutions. This second one, I want to isolate the variable as much as possible. So I definitely want to divide by 4 before I start messing with these exponents. Now I look and I say, okay, so x is raised to the 3/4. I want to raise it to something that's going to make it just to the 1st power. So that's why we practiced all those little reciprocals. I must do it to both sides. We still need to keep that balance, that equality. So that's x to the 1st equals, so this is what kind of root? The cube root of -3 to the 4th power. So I'm going to actually find out what -3 to the 4th power is, and that's a positive 81. If you can go further, awesome. If it doesn't come out clean, this is your exact answer. Once you put it in the calculator and get a rounded value, that is no longer exact. Okay, last one. Let's get that everything out of the way except for what's being raised to the power. So I divide both sides by 2. And now I see my variable and I'm trapped by an exponent of 2/5. And how do I make that an exponent of just 1? I'm going to raise it to the 5/2 power. Okay, so now that is just x minus 5 raised to the 1st, which is just x minus 5. And we have the square root, because remember, that's your index, of -1 to the 5th. So x minus 5 equals, this would become -1 after I raised it to the 5th power. And do you remember what the square root of -1 equals? That's our imaginary number, and it's represented by lowercase I. We add, oh, you know what? I just forgot a very important thing. I took an even root of both sides. So what do I have to remember to do? When I take an even root, I need that plus or minus. Even root, I need that plus or minus. Now over here, that was an odd root. So in that case, we're not going to need that plus or minus. Okay, the answer would either be positive or negative. It's not going to be both. The even root is where you can put a positive or negative in and get that same output. Okay, so very important there to make sure you remember that plus and minus. So that's going to be plus or minus I plus 5. So there's actually two solutions here that would work for us. Okay, we're going to continue to explore solving, but make sure you have that handout filled out, and that's what you can put in for your notes for this lesson.